Welcome to the project on apartment lighting layout. To do this project, you must have the following skill set, that is AutoCAD 2D, MS Excel Basic and Basic Mathematics. Participant will be able to implement lux level calculation for accurate brightness of light into the residential flat, lumens output selection, and proper distance between two lights. By this project, you will learn how to calculate the lux level, then lighting selection as per lumens output, and normal and emergency lighting arrangement as well as lighting distribution board. The target student for this project is electrical engineer or the draftsman, lighting consultants, or any student who is willing to do electrical or MEP design. By the end of this project, you will have the following skill set: comfort lux level brightness of the lighting, maximum lumens output by selecting accurate LED or CFL light. The project contains lux level calculation, electrical lighting layout, lumen selection chart. The case study says a residential building requires each apartment to install LED lighting as per lumens output and use minimum electrical power by providing the maximum brightness or the lux level to the area. So let's design the lighting layout using AutoCAD. Following scenarios will be covered as a part of this case study. Brightness or the lux level maintained in each corner of the required area of the flat, that is bedroom, living room, kitchen, bathroom, etc. Lighting looping separated for independent switching. Welcome to the new topic of electrical lighting layout. In this topic, we will learn how to design the electrical lighting layout for the residential building. For that, we required the architectural layout. In that architectural layout, we can see the living room, kitchen, bedroom, bathroom, WC, etc. So this is the typical flat detail or the flat layout for the residential area. In this flat, we will design the electrical lighting. For that, we required a certain inputs. The inputs like lux level, lumens output. For the luminaires, we are going to put here the luminaires. So each luminaires has the different lumens output. To find out the lumens output, we need to find out first the lux level required for this typical flat. Each area like living room, kitchen, bedroom and the bathroom has the different lux level. So according to this area, we need to find out the which lux level is applicable to these different areas. For that, I will prepare the Excel sheet for the lux level calculation. First of all, I will mention the serial number, then the area of application, and the standard lux level for that particular area. So for serial number 1, if it is living room, the standard lux level for the living room is 200 LX. The unit of lux level is LX. For the bedroom, the standard lux level is also 200. Whereas the kitchen requires 150 LX. The next room is the bathroom. Bathroom area or the bathroom, washroom requires 180 LX. And the WC area or the WC requires 200 LX. So these are some different LX or the lux level required for the same typical flat. So I will prepare first this list and then calculate the lumens output as per the lux level into the drawing. So this is lux level list. The lux level list I will extend by the passage, because into this typical floor plate there is the passage is also available, as well as the staircase is there, lift is there, so multiple common area is available. So I will put the lux level of each and every area. So passage required 200 lx, staircase required 150 lx, into the lift we require 250 lx. These are some standard lux level required for the residential area. So I have mentioned the living room, bedroom, kitchen, bathroom or washroom, WC, passage, staircase and lift, as well as the lift lobby. Lift lobby required 200 lx. So as per this, I will mention first of all save this list. So I have saved this list. Now I will calculate the lumens output as per this list. So to calculate the lumens output, this is the formula. Number of luminaires is equal to area of application into lux level value divided by MF, that is maintenance factor, UF, that is utilization factor, into lumens output. For example, if I am calculating the lumens output for this living room, I need to understand that I am putting only two numbers luminaires, that is the CFL or LED or any another unit required. If I am taking the example of living room, if I want to calculate the lumens output for this living room, I need to understand how much luminaires I am installing into the living room. For example, I wish to install the 2 CFL or the LED bulb into the living room, so the number of luminaires is equal to two numbers area of application, that is the living room. Into the living room, we need to find out the area of the living room, that is around 9 square meter. The living room area is around 9 square meter. Also, by calculating this area, like 2.4 into 3.75, that is 9 square meter. So according to this area, I will mention the 9 square meter over here, and the standard lux level which I have mentioned for the living room, that is 200 lx. So I will mention the 200 lx over here. What is the maintenance factor? Maintenance factor is the factor when we are maintaining that CFL or LED bulb year by year. So the standard maintenance factor we are taking here as a 0.7. What is UF? UF is the standard utilization factor we are taking is 0.6. So by this formula, I will calculate the lumens output. Take this value here . Is equal to 9 into 200 lx. By calculating this value, two into 0.7 into 0.6, 2 into 0.7 into 0.6, the answer is 0.84. So I will mention here 0.84 into lux level into lumens output. By this side calculation, there is 1800 . So lumens output is equal to 1800 lx divided by 0.84. So by dividing this 2142, the lumens output is 2142. This is the standard lumens output for the required living room. So my standard luminous, the numbers of luminous is 2 numbers. The lumens output is 2142. So I need to find out the accurate luminous or the applicable luminous required for this lumen output. For that, there is the list. So by this lumen calculation, if the lumen output is 2142, I will go to this list, the lumens output. These are the standard bulbs, that is LED, CFL, regular incandescent and the halogen. If the lumens output for the particular bulb is 450, for example, if there is the LED bulb and the lumens output for the LED bulb we have calculated is 450, so we need to choose this 6 watt. And if the lumens output for the LED bulb is 800, we need to choose 9 to 10 watt LED bulb. So this is the selection as per this chart. In this drawing, we have calculated the lumens output, that is 2142. So, in this list, the nearby 2142 is in between this 1600 lumens output or the 2600 lumens output. So, I will choose the nearby lumens output, that is 1600. If I want to put the LED bulb into this living room, I need to choose this 13 watts LED bulb. So here I will choose the 13 watts LED bulb for the living room. To put the 13 watt LED bulb in a living room, I need to mention the legend, that is so for this living room, what I will do, for this living room, here is the LED tube light, LED downlight, that is 15 watt LED tube light is there, then 10 watt to 12 watt LED downlight is there, then 8 watt to 9 watt LED downlight is there. So from this chart, I will choose the electrical LED downlight for the living room, or I will choose the 15 watt LED tube light. So my selection is 15 watt LED tube light. So I will place one tube light over here and another tube light over here on the wall. So here I have put the two 15 watt LED tube light as per this size. In the legend, I have also mentioned the 15 watt LED tube light. So I have mentioned over here also two numbers, 15 watt LED tube light, like this. So here I have mentioned the 15 watts LED tube light. For the kitchen, I will do the same calculation, that is number of luminaires. If I want to install the one LED tube light in the kitchen, the same calculation, number of luminaires is 1. The area of application, that is 3.1 square meter. Here is 3.1 square meter. The standard lux level from the list for the kitchen is 150 LX. Maintenance factor, (3.1). Lux level is 150. Maintenance factor 0.7. Utilization factor 0.6. And the lumens output. So how to find out the lumens output? Here I will mention 1. Here I will mention 3.1. and the lux level will be 150. Zero 0.7 into 0.6, that is 0.42, whereas here 3.1 into 150, that is 465. So 0.42 and here 465. So by this calculation, divide by 42, so 1100, this is the lumens output we have calculated. By this lumens output, we can see that which lumens output is applicable for the bulb. So this is 1100. If I want to put the LED or the CFL or the incandescent light, so these are the standard watts I need to choose. If I am putting the LED light, so this is 13 watt I need to choose. So in the kitchen, I will choose the 13 watt one number. For that, I need to change the legend of 13 watt. I'll make the block of that 13 watt LED tube light. Then I'll select the object, pick point. Okay. So this is my 13 watt LED tube light. The standard size of 13 watt LED tube light is 900 by 25 by 35. So what I will do, we need to put this 13 watt LED tube light into the kitchen. So next is the bedroom. Firstly, find out that how much luminous you want to put in the bedroom. In the bedroom, if there is a false ceiling, I want to put the downlight in the bedroom. So for that, if I choose the 4 numbers of downlight, so there will be 4 numbers downlight. Area of the application, that is bedroom. The area of the bedroom is around 6.11 square meter. So I will put here 6.11 square meter. The standard lux level for the bedroom is as per the list. Into the list, there is the 200 LX or the 200 lux level required for the bedroom. So I will put here 200. Now by this formula, I will calculate the exact amount of the lumens output for the bedroom. So here I'll mention the 4 numbers luminous, then 6.11 is the square meter area, 200 standard lux level required for the bedroom. So by this calculation, four into 0.07 into 0.06. That is 1.68. Whereas 6.11 into 200, that is 1222. So by this formula, 1222 divided by 1.68, the answer we are getting is 727. So lumens output here we getting from this formula, that is 727. So in the lumens output chart we can see 727 is nearby 800 lumens output. So if I am putting the LED bulb into that area, so what I required is the 9 watt per bulb. So here I am putting 9 watt each. I will select this nearby downlight, that is 100 mm dia. I will put the light into this bedroom. By dividing into two parts the bedroom, that is 2550 divided by 2, that is 1275 divided by 2, 637. So from here 637, the first line, that is here, and the next into 2, that is 1275. Here I will put the 1275, the next LED downlight will be here. Same here also, that is 637 from this side, and 1275 from here to here. Two 2400 divided by 2, that is 600. From here I'll mention the 600. So this is the standard 4 numbers downlight LED I have put into this bedroom area. Now next area is the bathroom. Into the bathroom I will put the downlight. So first of all I need to choose how many downlights I need to put into the bathroom. If I want to put a single downlight into the bathroom, so here I will mention the number of luminaire will be 1 and the area of the bathroom is around 1.8 square meter. So here I will mention 1.8 square meter. The standard lux level required for the bathroom is around 180 LX. So as per this list, I'll mention here 180 LX, and by this formula I will calculate the lumens output. So here 0.42, 0.42, and this side 324. 324 divided by 0.42, that is 771. So lumens output for the luminaire, each luminaire is 771. So by this value I will choose nearby 800. So LED I will choose, the one LED I will choose of 9 watt. The downlight LED I will choose over here, that is 9 watt LED I will choose and place at the center of the bathroom. So only one LED required for this bathroom area, that is downlight LED of around 9 watts. Now the remaining area is the WC. Into this I will again calculate the luminous or the lumens output. For that I want to put only one luminaire into the WC area, that is the toilet area. So for this area I will calculate the WC area, that is around 1.08 square meter. So here it is 1.08 square meter, and the standard luminous or the standard lux level required for the toilet or the WC area is around 200 lx. So here I will put 200 lx. So by this calculation I will find the lumens output here it is 216. So 216 divided by 0.42, that is around 515 lumens output. So by this calculation I have find out the lumens output 515. So here is the list of lumens output. It's a nearby 450. 515 is the nearby 450. So if I want to choose the downlight LED, it will be 6 watts. So I will put the 6 watt LED over here. So for that I need to make one legend for the 6 watt LED. For example, this is 4 to 6 watts LED downlight. The size of the LED downlight is standard 75 mm. I'll make the block of this 4 to 6 watt. Or maybe 6 watt. So I will put the 6 watt LED into the WC. So these are the standard installation I have done for the luminaires. So till now we have calculated the lumens output and the luminaires required for this typical flat. We calculated the lumens output and the luminaires required for this typical flat, that is living room, kitchen, bedroom, bathroom and the WC. here is the passage area. We also calculate this passage area into the lumens output. So how to calculate the luminous required for this passage area is the same. Like, first of all, measure this area of the passage. This is around 2.15 square meter. This is around 2.15 square meter. So by the same formula, I want to put the one luminaire into this. It may be downlight for this passage. So I want to put the one luminaire. The area is around 2.15 square meter. So I'll mention the 2.15 square meter. The passage. Now see the list. If the passage required 200 lux level, so I will mention the 200 lux level. By this formula, I will calculate the required lumens output. That is 2.15 so 2.15 into 200, that is 430. So 430 divided by 0.42, that is around 1023. So lumens output for this area for the passage is 1023. Now taking this lumens output, I will find out that which luminance is applicable for the passage area. This is around 1100 lumens output. So if I am taking the LED, it will be 13 watt. So I need to put the 13 watt LED or the 13 watt tube light into this area. So if I want to the 13 watt LED downlight, I need to choose this 10 to 12 watt LED downlight, that is, and I need to put at the center of this passage area. So this is, I have completed the inner lighting of the typical flat. If I want to put LED downlight into the balcony or the CFL bulb into the balcony, I will put like this. If I want to put the CFL bulb into the balcony, I will put over here. Like, I need to first prepare the legend of the LED light. If I want to put the side bulb into the balcony, it will be like this. This is the standard CFL side bulb for the wall. for the wall mounted bulb, CFL wall mounted bulb. I will put the single bulb for this balcony wall mounted area. So how to calculate the lumens output and the watt required for this side wall bulb? Go into this formula. In this formula, if I want the number of luminaires is 1, the area of the balcony is around 2.4 square meter. The balcony is considered as a passage, so I will take 200 lux level for the same. So by calculating this formula, (480) so 480 divided by 0.42, that is 1142. So in this selection chart, lumens output, if 1142 is the standard lumens output calculated for this balcony area, and I want to select the CFL bulb, so it may be around 18 to 19 watt CFL bulb I need to choose. So 18 to 19 watt CFL bulb is around for the balcony area. So this is I have completed a typical flat for the electrical lighting layout. So I have completed this typical flat details. Then I want to copy this to the each area. For that, I can easily, as I can see, this flat is the typically mirror image of this flat, so I can directly mirror of these details of LED lights into this typical flat. For that, I will lock the layer first and unlock the LED light layer. This I'll prepare first the text. So here I will directly mirror this by taking the midpoint of here. So it will be looks like this. It is the same mirror image. Here also we need to install the same LED light. Same CFL bulb. So this is what I completed. This typical floor has the typical flat of the mirror image. So I can easily mirror these two flat I can definitely mirror this two flat with this typical flat, as well as this 4 flat with this typical flat. So here I have completed the input of the luminaires into each area, that is living room, kitchen, bedroom, bathroom, WC, passage and the balcony. So you can see everywhere I have put the luminaires as per the requirement and as per the lux level calculation and the lumens output. By this I have mirror everything so it looks similar. These typical flats are look similar and the typical flat is on the typical floor, so I have mentioned like this. So this is what I completed, the luminaire installation into the typical flat. Let us talk about how to connect the looping with this typical flat. We need to install the lighting, the luminaires into the passage area, that is the normal lighting as well as the emergency lighting. Into the passage we will install the normal lighting and the emergency lighting step by step. For that I need to prepare the legend accordingly. To calculate the lux level or the lumens output for this passage area, we need to find out that how much luminaires we require. For example, I have taken the 9 luminaires in a normal and 9 numbers, that is the emergency luminaires I will take. For that I will calculate the number of luminaires, that is 18 numbers of luminaires. 9 numbers is the normal and 9 numbers in the emergency. So 18 numbers of luminaires will be there. And here the same calculation, the area (65.2), I have already mentioned the area. The lux level required for the passage is around 200 lx. So I have mentioned over here. Maintenance factor is 0.7, utilization factor is 0.6. So, and the lumens output we need to find out. So by this formula, here it is put 18. So 18 into 0.7 into 0.6, that is 7.56, and here 13,040 by this multiplication. So 7.56, 13,040 divided by 7.56, that is around 1,724. So it is approximately 1,725. So this is the lumens output for the passage area. So we need to find out the LED light accordingly. For example, here is the nearby 1600 is the lumens output, which is nearby 1725. So I will put, if I want to choose the LED downlight, so I will put 16 to 18 watt LED required for that area. So from here I will start by the 900 mm from here and put the central line over here. Into this center line, firstly I will mention this LED. For that, firstly we mention 16 to 18 watt LED. So here I have changed the legend for 16 to 18 watt LED downlight. The die will be the same, that is 150 mm. So I will put this LED into the passage like this. Again I will to put same 16 by 18 but for emergency. Here I will put the emergency. So one is alternate emergency divided into the 18 numbers. So here I have mentioned some emergency as well as the normal LED lighting of 16 watt emergency LED downlight and 16 watt LED downlight. Here it is, I want to mention the LED downlight. From here I want to put the emergency light like this. So alternate one emergency light, one normal light I am putting into this passage area. Now we are going to looping of this luminous step by step. So I will make the two loop. The one loop is for bedroom and living room. Another loop is for kitchen, bathroom and WC, or the three room. The three separate loop I will do, that is one for bedroom, one for living room, and the last one, third one is for kitchen, WC, passage and the bathroom. And I will put the main distribution board over here. This is the main DB. I'll make the layer of the DB. Lighting loop 1, lighting loop 2, and lighting loop 3. So I have choose 3 lighting loop. So first lighting loop from living room to the main DB. So from here I'll put the lighting like this, the loop like this. Here it is, the loop. The second loop same from here to this light. Again I will put this balcony light into the living room looping. Now for the WC, there is the switch and socket, or only socket required for the WC. Only switch required for the WC, like this. Here we are going to put the switch and socket. Like this. This is single way socket and the switches. One, two, three, four. So 4 number of switches and 2 numbers of sockets. 1, 2, 3, 4, 5. So what we require is the 5 numbers of switches, like this. In the kitchen, we require switch and socket. At this point, for the bedroom, There will be the third loop. Two bulbs can be connected like this. So here each and every luminous has been connected with the looping, and the loop is going to the main switch and socket. The bathroom has been removed. For this bathroom, there is one switch and socket required for the bathroom. The socket required for the geyser or maybe something else, and there will be the two switches. One is for lighting, another is for 6x16 ampere socket. So this is the typical looping for luminous. This typical looping can be copied into the each flat. For that, we need to do the layoff command. Like this. Now connect this luminaires. One is the normal and another is the emergency. So for that, I will connect this with the main dB and the emergency dB. So there will be the 2 dB at outside the passage. Maybe in the electrical room or outside, or it is nearby the staircase. Or it may be in the electrical shaft. So here is the electrical shaft. I will provide the electrical dB or the lighting dB into this, like this. So this is the standard dB into the electrical shaft. Now the looping is going like this. For that, we need to provide the loop number 4. So there is the loop 4, and this loop 4 as well as lighting loop 5 for emergency will be there. So for loop number 4, we need to connect the normal luminaire with that. Next is the emergency loop. So here it is, the emergency looping. So one is for normal and another is for emergency looping. This is what we need to do for the looping purpose. To connect the luminaires with each other, there must be in a different loop. For the living room and balcony, there is the one loop. For kitchen, WC and passage area, there is another loop. For bedroom, bathroom, there is the third loop. So by this looping, we need to connect the luminaires with each other. The same typical flat is connected by this looping, and in the main passage, there is the main normal LED and the emergency LED. So this is the lighting layout by the luminaire calculation. This is the standard formula required to calculate the lumens output So the title for this drawing is Electrical Lighting Layout for Typical Floor Plan. This is the standard formula required for that. Legend is also there. Here is the legend. So this is the complete layout for electrical lighting, typical floor plan. The rest of the thing is that we again need to give the lighting for the staircase as well as the lift. So for this, I'll copy this lighting over here. One is the normal, another is the emergency, again there will be at the mid landing, one is the normal, another is the emergency, then the lift, one normal lighting, one emergency, same at the next lift, one is normal, one is emergency lighting, like this. Here is also into this staircase. One is the normal and one is the emergency lighting, like this. At the mid lighting area. So this is also comes into the loop. Emergency lighting loop will become like this. Whereas the looping for this main and emergency lighting in the lift is coming directly from the lift room, so we cannot connect this lighting over here. So this is the connection only for the staircase lighting. Again here we need to put the staircase lighting like this. Emergency lighting from here. The main lighting like this from here to this, and from here to here, from here to here, and again from here to here. Firstly, try to maintain the nearest connection like this. So this is the nearest connection for the electrical lighting. So we have covered the typical flat, passage and the staircase looping for the electrical lighting, and this is the legend. This is how to design the electrical lighting layout for the typical floor for the residential area.